Hello, this is Ms. Schultz. So we're gonna do the very intro to transformations. Okay, so write the dates. Okay, so we've gone over this, but as a review, all right, let's graph these functions. And also you might know the general shape, or perhaps not the very specific points. So x squared goes through 0, 0, 1 squared is 1, negative 1 squared is also 1. 2 squared is 4, 2, 4. Negative 2 squared is also 4. That's why the square root of 4, that's why x squared equals 4 has plus or minus 2 is the answer. Okay, so then you make your parabola. Okay. This is the inverse function, but just the positive, it's just the plus. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. Recall, if you don't know what a graph looks like, you can always substitute in points. For this one, you want to substitute in quote-unquote friendly points. So square root of 3 you don't want to do, but square root of 4, that's a friendly point. X cubed, 0 cubed is 0, 1 cubed is 1, negative 1 cubed is negative 1, 2 cubed is 8. Let's see if this goes up to 8. If not, we can extend it a little bit. 1, 2, 3, 4, 5, 6, 7, 8. And negative 2 cubed is negative 8. So it's like a parabola, but this parabola has, let's put our arrows on. So when you graph x squared, it has a turning point. So negatives, inputs become positive outputs. So no matter what, when you have an even exponent, all your outputs are positive. That's why this has, the vertex is a turning point. Negative inputs are negative outputs here. So this is why this doesn't have a turning point and it continues to be negative. X to the fourth, so you have 0, 0. So this, all positive outputs, just like x squared. And 2 would go up to 16. This is more of a U than a V here. So it looks very much like a U. All right, the cube root of x, let's do this. So the cube root of 1 is 1. And it looks like this, and you'd have the cube root of 8 being 2. There we go. So those are our parent functions with precision. So when you're doing transformations, I expect you to plot at least 3 points with precision. Okay. So let's talk about this function machine. There's inputs and outputs, okay? So this is in, this is out. Okay, so when things that affect the input would be like f of x minus 3 changes it before it even goes in. So for example, x minus 3, if you put in a 3, so x equals, so x equals 3 would make it, makes the input 0. So in other words, it takes the opposite sign to bring the input back to 0 or back to x. Like 3 minus 3 back to x or 0. So this is why, so it's the opposite sign. So if you have f of x minus some a where a is positive, this will move right a. So this is opposite. It's a minus, but it's still going to move right a. F of x minus x plus a, so it'd move left a. So things for the input do the opposite of what you expect. That's what I'm trying to say. A minus becomes a right, and a plus becomes a left. Things that change the input do the opposite of what you say. Now we have things that change the output. So if I have f of x plus a, where a is some positive number still, so a is always a positive number. So these are changing the output. So this would move up a. So you have your input, you just take your y value, your normal y value, whatever you would get, and then you add a. okay? Then you would add a. So simply, you take your y value and then you add a, so up a like you would think. F of x minus a would go down a. Okay. So let's do these examples. So there's multiple ways to do this. You could just do it by plugging in numbers, but we're going to do it using transformations. So think about what this minus 2 does and what the plus 1 does. All right, what do those two transformations do? All right, and we're back. It goes right 2 and up 1. So I take my starting point for this. The starting point for x squared is 0, 0. Would you mind getting the door, guys? Thanks. It's okay. Oh yeah, don't make a big point there. So 0, 0. So I'm going to take that, go right 2 and up 1. So this is my starting point. And from here, go ahead and choose the rest of the graph, please. Okay, so from here, I know that 1 squared is 1, so that doesn't mean I have the 0.11. That means I start here, this is important, so for precision, go right 1 and up 1, and left 1 and up 1. Okay, so you're pretending like this is the origin, basically. So you know 2, 4 is normally a point, but it's not going to be actually 2, 4. It's going to be over 2 and up 4 from the vertex. That's right, 1, 2, 3, 4. Yeah, so not from this point, but from the center, you go over 2, up 4. And that's my parabola. Okay, let's do this one. So go ahead, list the transformations for this. All right, and we're back. It's left 3, down 4. So normally I would start at the origin, 0, 0, because square root of 0, 0. So that's for my parent graph. I started 0, 0. So I'm going to go left 3, 1, 2, 3, and then down 4, 1, 2, 3, 4. Okay? And then normally I know 1 squared is 1, so normally like I would have 1, 1 as a point, but I just go up 1 over 1 from this starting point. Normally I'd have 4, 2, because the square root of 4 is 2. But I take this and I go over 4 up 2 from this starting point, my new origin, if you will. Not from here, but I start at my original point. I go over 4 up 2. I could also go from here over 9 up 3. I might have room. I think I do. So 3, 6, yeah, over 9. So this is over 9, up 3. This is extra. I wouldn't expect that on a quiz or a test, but there we go. All right, list the transformations of this bottom one. All right, left a half, down 2. So left a half, yes, you can go left a half. It's in between -1 and 0. And then down 2, okay? And from here, I'm making my transformation. So name 2 more points that would be on it. I would do it visually first, and then try to work it out. All right, so normally I go over 1, up 1, because 1 cubed is 1. So I start here, I go over 1, so I'm at positive a half, up 1, negative 1. Okay, and then I go over 1, so I'm at -1 and a half, down 1. Okay, and I can just make my cubic from here. 3 points is what I require. All right. Okay, we're going to do this last slide, equation of a circle. This is for funsies. This won't be on a quiz or a test, but so I'll have, this is the equation of a circle, x minus h squared plus y minus k squared equals r squared. The reason why I write minus is to remind us that it's the opposite way. So like if h is 3, I am going left 3. So this minus just indicates it goes opposite from what you would think. And h, the center here, would be at h comma k. So here's the center. All right, so here my center is at -2, 1. All right. And what is my radius? Look at the radius. My radius is, I can find it anywhere, 1, 2, 3, or you can go here, 1, 2, 3, 1, 2, 3, r equals 3. So go ahead, substitute in these points. So the h is -2, and the k is 1, and the radius is 3. So write the equation of this circle. All right, it would be x plus 2 squared. So from my center, if my normal center is at the origin, this means I'm going left 2, boom, boom, plus y minus 1. This means I'm going up 1, so left 2 and up 1. Squared equals 3 squared, which is 9. Okay. So that is your introduction to up, down, left, and right of transformations. Again, the summary is that when you change the x value, that's changing the input, is backwards from what you think. When you change the y value, that's changing the output. It does exactly what you would think. Okay? All right, bye-bye.